In this short tutorial, we will review the vertical debiasing workflow for the True View 410 system. The same principles that we use in this workflow can be applied to any PPK or RTK GNSS process derived dataset. For instance, traditional airborne laser scanning or dense image matching. Even when correctly performing GNSS processing and having a calibrated LiDAR sensor, which we've done with the TrueView 410 system, there can still be some bias in the dataset relative to ground truth or checkpoints. So recall that the vertical component of GNSS solutions is usually the weakest. So we can use the control report function in TrueView EVO to ascertain the bias value, and then we can use a point cloud task to remove this vertical bias. So let's go ahead and I'm going to pull up a TrueView EVO project. This is a TrueView 410 dataset. And the first thing you want to do when you have a TrueView 410 dataset for this workflow is add your control file. You can add it either with the Add Data button up here. You're going to add a feature file if it's already in shapefile format or one of the supported formats, or a lot of times our customers will have their control uh, data in text or CSV format. And if that's the case, you go to File, Import from ASCII XYZ, and that way you can go through that process and import convert your text file to a shapefile format that we can use for this process. This process for importing from ASCII and converting that to shapefile is covered in another one of our tutorial videos. You can find that and other tutorial videos that would be useful at support.geocu.com. There's a whole slew of little uh, short workflow videos for LP360, and those would apply to TrueView EVO as well. So once you've imported your control file, which I already have, you can see the little red dots on the screen in the map view. Um, we're ready to begin the process. Just keep in mind that this control file needs to be in the same spatial reference system as your TrueView dataset. So the next thing we want to do once we've imported this file, you can see it in my table of contents, is we're going to go to, we want to make sure our control points toolbar is turned on. It's this toolbar right here. This is the default location. And you're going to select that shapefile that or your control file that you've imported in this drop-down menu. And then you'll select this button on the far right to open up the control points report dialog. Now just keep in mind we want to make sure we're using valid points for this comparison. So you want to make sure your points are on a clean level surface or location on your project. So definitely don't want to have control points or checkpoints in grassy areas or on slopes. Definitely not next to tall buildings or vehicles. Just make sure they're nice open flat areas. And so with that in mind, this project that I'm reviewing in this example. This is a site we fly all the time. So I've marked my control points and checkpoints accordingly, and even the points that either fall outside of my project area or they're in grassy areas, I've marked accordingly as well. So the points I'm going to be using I've marked as FC for full check. The points, if possible with this project, with this workflow, once you've done your debiasing, it would be good or it's recommended that you have some checkpoints, some additional checkpoints to validate the accuracy of our debiasing process in your overall data set as it relates to those checkpoints we've left behind. So I've done that as well and labeled those as FK. Um, Now, if you're bringing in this control file and you haven't labeled all these, one nice thing you can do, I'm going to zoom in a little bit on the map view, is you can click through these in the menu. It's going to drive you right to them. I can clearly see that these points that I've labeled FC are falling where there's data points. And if I scroll down to the IPs, you can see I've either got points in some really bad grassy areas or they're outside of my project. So I've labeled them IP so I don't include those when I'm doing my work. Also, this one at the top is labeled BS. That's my base station point. So obviously you don't want to use your base station point either. You've got your base station equipment on top of the point during the flight, so you don't want to use that for this process. So the next thing I'm going to do, since I've labeled my points, this is I've labeled them as these types. So I'm going to select my FC type, my full control, and it's automatically going to turn off my other points, my points that I'm not going to, obviously not going to use because they're outside my project area, and also some extra points that, again, that I've collected to do an accuracy assessment at the end of this process. Okay. For method, instead of using a triangulation, we want to choose inverse distance weighted. Okay. We recommend using the inverse distance weighted option when running the control report function uh, because data from these lower quality scanners tends to be a bit noisy, and just using 3 points, which is what the 10 method would do, um, makes for a noisy model of the surface. With this inverse distance weighted, or IDW, this should give you a little better estimate. It's less noisy, a better estimate of the ground elevation, especially if the guideline about setting checkpoints in a clear and level spot is followed, as I've already mentioned. So let's go ahead and do that. I've changed this to 1. Okay. And now all I need to do is click calculate DZ, and this is going to calculate the distance vertically between the control points and the point cloud surface. Click OK. So this is telling me that these points are outside of my data set. Now just keep in mind, these are not my ID numbers over here on the left. This is where they fall in the list. So point 13, 17, and 18, as you go on down the list, those are outside of my data set, and you saw earlier where I marked those as IP, okay? Okay, so this is telling me if we look on the right side here, the vertical section, we're not concerned with the horizontal section for this workflow. Uh, uh, my mean error is negative 2.4 centimeters. So the distance between that point cloud and the uh, control points on average is 2.4 centimeters. And we have some other statistics here as well. But we're mainly concerned with this because we're going to shift the point cloud based on this. And so once we shifted the point cloud, we assume that this is going to drop to 0. Some of our other accuracy values are going to drop as well, so that's good. Uh, so basically, the average uh, distance between these, the point cloud and the control points, we're going to basically shift it to where those are a lot closer in value. Okay, so I'm going to hit OK here. Next thing we want to do is create a point cloud task. I'm going to click on my point cloud task tab here. And we're going to go to, we want to use the affine transform LAS point cloud task. If you want to add a new one, you're going to click on this gear icon on the top right, and then click add, select your task type, which is affine transform LAS, and name it whatever you would like. And then you'll click OK. You'll go through these dialogues and it'll show up in your list just like it has on mine. For our input LAS layer, we want to just use our active LAS layer that we generated through the True View EVO processing. Um, just keep in mind too that for active LAS layer, we have an option here. There's a button that's depressed. This is a single LAS mode. This only allows one LAS layer to be shown at a time. So what we're going to be doing here is generating a new LAS layer. When we do some additional processes, we want to make sure we switch to the correct LAS layer. And if we have this button depressed, we can make sure that only one LAS layer is being displayed at the time. We're not choosing our original LAS, so we won't get all confused. So just keep that in mind, and you'll see that in a little bit. You'll put that value in the translate dialog here. So you want to make sure you're going the same direction. So as you saw in the control report dialog, it was negative 2.4 centimeters. So we need to put the same value here and in the same direction. So we're going to scroll down to the bottom, and you just want to make sure your output is set accordingly as well. If we click maintain source file structure, it's going to keep the same number of files and the same naming convention. So just make sure you choose an appropriate spot for that output folder. Okay. So now I'm going to run this by project, now that I have my settings the way I want them. All right, so that process is complete. So I've just created a new point cloud, shift apply. So my active LAS layer setting at the top, I'm going to select that. Um, let's go to our table of contents real quick before we do that. And just so we don't get confused, we're going to change this to Debias, so we know that that's um, the the point cloud we just produced. And if you, as you see up here, when we select our active LAS layer, it's going to reflect that naming convention. Okay. So what we want to do next is go back to our control report dialog. We're going to select the same thing. We're going to use our full control, and we're going to do calculate DZ again. And we should see that value go to 0, and we did. And like I said earlier, if possible, you want to set up some checkpoints to validate this shift that we just did, and also it'll serve as your accuracy assessment for your project. So I'm going to change the quick set to full check, and you see it automatically calculated, but just for good measure, we'll click on calculate DZ again. And you can see we're a lot better. Um, uh, our point cloud is much closer to our checkpoints than they were to the control points before. So you can see that shift was successful in getting our data set closer to that ground truth. And this is really important um, if you're going to be flying the same project area multiple times. This is a good method for making sure your point clouds match up from project to project. If you need any additional assistance, please contact us at support@geocu.com. Hopefully this has been useful to you, and we'll see you next time.